So we're going to be getting started with chapter 16, and this chapter involves percentages. Percentages uh, pop up in several places. We use percentages in terms of students' grades. We use percentages when we talk about discounts at stores, and we're going to be working some problems in the next chapter where percentages are used for interest rates and chemical solutions, mixtures of different things. So, very important that you understand percentages, and it's basically a different format of a number. Okay, if you read here, it says a percentage means divided by 100. So, for example, if you were to see 5 with the percent sign beside it, then to translate that into a regular number, a decimal number that you may be more used to dealing with, then you would simply take 5 and divide it by 100. Or you could write it as a fraction, 5 over 100, and at that point you would drop the percent sign. Example 1, they've drawn a picture for us. We have some of the blocks are shaded, some of them are not, but how many blocks do we have total? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this square here is 10 blocks by 10. So we have 10 times 10, 100 total. Alright, how many do we actually have shaded? And that was the question, what percent of the figure is shaded? Well, we could say we have 3, and then if we run the lengths of this bottom piece, then let's see, that is 3, 4, 5, 6, 7, 8. So if I chopped off this bottom part, I would have 3 times 8, 24. And then I'd want to add this top piece that's shaded, and it is, let's see, 1, 2, 3, 4, 5 cubes wide, and it is 4 cubes high, so that's 4 times 5, and that gives me 20. And then I just simply add them together to get 44 shaded cubes. So to represent the shaded portion as a percentage, we would take the number shaded and divide by the total, 100. Okay, and then since this is the fraction form, then we would multiply it by another 100 with the percent sign. So percent is based off of 100, so our 100s cancel, and we're left with the percent sign, and so 44% of this larger 10 by 10 cube is shaded. Okay, you need to know how to convert back and forth between percentages pretty quickly, and you can actually do it very quickly by simply moving the decimal point. Okay, we've already talked about 5% and how it is the number divided by 100. Well, that's what .001 is. This, you put it in your calculator and check it, is 1 over 100. So multiplying by 1 over 100 is the equivalent of dividing by 100, or multiplying by .01. Okay, now put this in your calculator and you will see that the decimal point simply moves to the left 2 places. Okay, whenever you divide, and you only divide a particular number by a number that's based on 10, 100, 1,000, 10,000, when you divide by that number, you can simply count the zeros, 1, 2 in this case, and move the decimal point to the left that many places. So, for instance, if we had 5 times 1 over 1,000, then we would simply take 5 and move it 1, 2, 3 places to the left. But that's just for your own information. We're dealing with percentages in this chapter, and so we're either going to be multiplying by 100 or dividing by 100. So we either move the decimal point 2 places to the left or back 2 places to the right to get back to the percentage. And that's exactly what we do in this part, the top of this page. We start out with a number that has no percentage sign. It's just a decimal 0.05. Well, if we now take the decimal point and move it back to the right 2 places behind the 5, and these arrows here are the equivalent of multiplying by 100. So we have multiply by 100 out to the side, and this is what we're doing to carry out that multiplication. We're moving the decimal place to the right, and now we have 5 with a decimal point behind it, and now we can insert our parentheses, or I'm sorry, our percentage sign. So in the end we get 5%. So with example 2, we are given a decimal format of a number, and we want to write it as a percentage. So to go from decimal to percentage, what do we do? Okay, we move 2 places to the right. Okay, we move the decimal point. So we would take 0.074. The decimal point was right there originally, and we move it 1, 2 to the right. And now we can put our percentage sign behind it. In the end, we want to drop these zeros because the 7 is now sort of in the ones place, and we only need the 7.4 with the percent sign behind it. To go from 529 back to the decimal, then we have a percentage, and you can think of this as writing decimal on the left, percentage on the right, because that would be alphabetical order. So we place our percentage here, and with respect to the number 529, our decimal point is located right there behind the 9. So when we transform it back to a decimal number, we move the decimal 2 places to the left. And we actually had to go from percentage to decimal, writing these 2 words in alphabetical order. We actually have to go over here to the left. So maybe that'll be a good way for you to memorize it. So if I take 529, I'm going to have a decimal once I move 2 places to the left, so I don't need to write the percent sign. The decimal was located behind the 9, 1, 2 to the left, and to write that without the arrows and the X, I would write 5.29. And so here is the decimal form of 529%. Example 3, converting a percentage to a fraction. Write 35% as a fraction in simplest form. Oh, I misspelled that. Decimal on the left, percentage on the right. We already know how to switch back and forth between these two formats. And so to go from percentage to decimal, I'm going to the left, and I should have drawn my arrow that way. Let's see. Oh. Reverse my arrow there. I want to go to the left from percentage to decimal. So as before, I moved 2 places to the left. The number 35 is interpreted as having a decimal point there, and I move it 1, 2 to the left, which would give me a 0 point. I could just write 0.35, or if I wanted to, I could put a 0 in front of the decimal point. But as a decimal, that is 0.35. Now that I have a decimal, it should be easier to see that what is the last place value in this number. Well, I'm going 2 places to the right from the decimal point. I have a tenths, and then I have a hundredths. And so with the 5 being in the hundredths place, our last digit, I would simply write 0.35 equals 35 divided by 100. Or you could simply put 0.35 in your TI 8486 calculator, go to math and select fraction, and it would do it for you. However, it wouldn't write it based off of 100, because 35 over 100 is, you can simplify it. So the reason we can simplify it is because 5 divides into 35 and 100. So we divide the top by 5 and the bottom by 5, and we end up with 7 over 20. And that's what the instructions told us to do. Write 35% as a fraction in simplest form. And so we need to end up with a fraction that does not have a common divisor between the numerator and denominator. And this fraction is the one we were looking for. So I simply took my percentage, I moved the decimal place left 2 spaces to convert it to a decimal, and then I took the decimal and I converted it to a fraction, and then I simplified it. Example 4 wants us to convert a fraction to a percentage. Write 80 over 50 as a percentage. There are actually a couple ways you could go about this. We know that a percentage is a number that's based off of 100, and what this fraction is based on right now is a 50. However, a 50 is easily converted into 100 by multiplying by 2. If we multiply the denominator by 2, we have to multiply the numerator by 2. So we can scale this fraction up to get 160 over 100. So then if we actually divide 160 by 100, we would get 1.60. We have a decimal format of a number. If we want to switch it to a percentage, then we simply move the decimal point to the right 2 places and place a percent sign behind it. Or at this point you could have said, well, a percentage is a number based on 100. So with 160 divided by 100, you could have jumped straight to the numerator 160 and then placed a percentage sign behind it. Either way is definitely acceptable. An alternate route you could go is to take 80 divided by 50, and if you plug that in your calculator, you would get 1.6, and so we would arrive the same place we were up here with the 1.6, and we have a decimal number. To get it in percentage form, again, we would move the decimal place to the right 2 places, getting a 160, and then we'd simply place a percentage sign behind it. Next page, 6.2, the percentage equation. Recall, percent means divided by 100. So workbook wants us to write each of the following percentages in decimal form. So we took a percent and we wanted to go to decimal form, so we moved to the left, 0.72. 50% is half of something, and 1/2 as a decimal is, as you would expect, 0.5. So we move the decimal place to the left twice again. 120%. The number 120 has a decimal point right there behind the 0. If we move it to the left 2 places, we end up with a 1.2. Okay, so we're going to go through 3 different versions of a percentage question. And these questions are going to contain the word what, is, and of. When we see what, we replace it with a variable. When we see is, we can replace it with an equal sign. And then when of is placed between 2 numbers, we simply multiply the 2 numbers. For instance, half of 30, half of 30, well, that would just simply mean we multiply the 2 together and we would get 15. So the first version we look at, what is 80% of 84? What is replaced with a variable x. Is replaced by an equal sign. And now we take our percentage, and the number is 80. but we want to convert 80% to a decimal before we actually carry out any mathematical operations. So 80% to a decimal, there's the decimal place for the 80 with the percent sign. We would move it to the left to get a 0.8. Alright, so instead of placing 80% in our equation, we will place 0.8, and the 80% of 84 means that we multiply this decimal version of the percentage times 84. So, pull up my calculator and I type 0.8 times 84, and we get 67.2. And so we didn't really have to solve an equation in the regular sense. X was already by itself on the left, and so X is what number? Well, X equals 67.2, so we're done. Example 6, another version of a percentage equation. We have the percentage of what? Alright, so once again, any percentages that we end up with, we will convert to a decimal number. Percent to decimal, we move to the left, 1, 2. So I would have a 0.32. Of means that we're going to take 0.32 and multiply it. What means that we are going to use a variable in the place of some unknown number. Is translates to an equal sign, and I mixed my arrows. I don't want you to get confused. And then we have 78. So we can just go from start to finish in line with the sentence, the question, replacing each component with a decimal number, a variable, an equal sign, or another number. So this is actually going to require what most would consider to be a little bit of algebra, where the x is not by itself, as example 5 was. So to get the x by itself, we take our equation that we have, we take note of what's happening to the x. It's being multiplied by 0.32, so we divide by 0.32. 0.32's cancel on the left, and we have x equals 78 divided by 0.32. That would be quite a bit of work to actually divide it out by hand, so we will pull up our calculator. 78 divided by 0.32, 243.75. So we're not always just simply taking the percent and multiplying it by a number. You could end up having to divide a number, okay, by the decimal version of the percentage. And once again, we never use the percent form. We always convert it to a decimal whenever we're dealing with mathematical operations. Alright, applications. Mentioned earlier that percentages most commonly pop up when there's a sale at a store for a particular item. So if we look at our first question, it reads an item is discounted at 30%. What percentage will be paid? Alright, well, if we pay the full original price, then that is considered to be 100%. However, if it's discounted 30%, then that means we're taking the original percentage price and we're subtracting 30% from it, and so we are going to pay 70% of the original price. And as you may notice, this isn't really in relation to this formula that we were given, where to calculate the sale price, we take the original price and we multiply it by the percentage to be paid. And with this first question, we were simply calculating the percentage to be paid. So we knew the discount, but the discount percentage is not included in this formula that we're giving you. So we have to take 100%, subtract the discount, and use this 70% in the place of percentage to be paid. So let's look at example 7. We have sale price equals original price times percent paid. Okay, the percentage to be paid, I'm sort of shortening this up a little bit. The problem reads an item is at regular $70. It is now priced at a discount of 20% off the regular price. What is the price now? Well, we know we need a percentage, but this 20%, it's important to realize that this is not the percent that's going to be paid. This is discounted percentage. Discount, not the percent paid. So what we do is we say 100% minus 20% equals the percent paid. Well, 100 minus 20 is 80. So the original price was $70. The percent paid is 80%. And at the same time, as you probably just noticed, we should take the 80%, move the decimal place to the left twice to get 0.8. And we use the decimal form in the calculation. Once we multiply these two numbers, we get our sale price. 7 times 8 is a 56. And so 0.8 times 70 would be 56. This is how much we would actually pay after the 20% discount. Example 8 reads, Caitlin bought a suit on sale for $230.40. This was 20% off the original price. Okay, so this 240 is the sale price. This price is after the 24. And so what we don't know is the original price. Alright, to recall our formula from the top, we have sale price equals the original price times the percent paid. So the price is 20%, 24% of the original. Okay. When it says this price, you have to realize that it's referring to the $230.40, and it said was 24% of the original price. So they are not giving us the discount here. Okay, they're actually giving us the percent paid, because we're taking original and we have this keyword of in between. So I'll replace original with X. Percent to be paid would be the decimal form of 24% of 0.24, and then our sale price would simply fall into place on the left side. Dividing both sides by 0.24. Pull up our calculator, and we type 230.4 divided by 0.24, enter. We get 960. So it was originally priced at $960. So you have to pay close attention to the wording. If it doesn't say discount, they may have given you the percent to be paid. Here we are in a different situation. We want to calculate the interest that a particular account pays. We see that we can calculate the interest by taking the principal and multiplying it by the percentage rate. Okay. Now I know this says percentage, but once again we're going to take our percentages and convert them to a decimal number. If we want the interest over several years, then we still simply just multiply the principal, the money that's placed into the account when it's created, multiply by the decimal format of the percent, and then just multiply by the number of years. And this is most commonly referred to as simple interest. Most checking and savings accounts and CDs, they operate on compounded interest, which is a slightly different way and probably more accurate way to calculate interest. But for this chapter, we're just simply going to use simple interest if the interest is left in an account for multiple years. So time would be in years. Sample 9. Chang deposits $7,000 into an account that pays simple interest at a rate of 2% per year. How much interest will he be paid in the first 6 years? Okay. How much interest? Well, that's what this answers. Interest for multiple years. Well, how many years? 6, that would be our time. We need a principal, that would be our 7,000. And finally, we have our percentage rate, which would need to be converted to a decimal, 2%. So for multiple years, we would write 7,000 times, okay, 2% converted to a decimal. We move it to the left 1, 2, and we fill in any gaps with a 0. And so we would have 0.02 as a decimal. We would insert that into our formula. Then we have time, which is 6 years, so we place 6 in our formula. And this is our interest, which I'll simply write an I in the place of. At this point, we could pull up our calculator and type 7,000 times 0.02 times 6, enter, and we get $840. We get dollars because percentage and or the percent 0.02, and then the 6 have units of percent per year, and then the 6 has units of years. The years cancel, and I say this is a percentage, but it's actually a decimal, and so there's no units associated except for the per year part. There's no units associated with the 0.02, so when the years cancel, we just simply have a number times the dollar amount, and so we end up with the same units as the $7,000, which makes sense. We're calculating the amount of interest that we're going to get, and interest is paid in dollars. And apparently that was our last example for the percentage chapter. At this point, you just need to go to ALEKS and make sure you get plenty of practice.